Welcome to doassignment-ca. Here's the problem. A 10-pound block has a speed of 4 feet per second when a force F equal to 8t squared pounds is applied horizontally. Determine the velocity of the block when t equals 2 seconds. The coefficient of kinetic friction at the surface is mu sub k equal to 0.2. Now, let us work through the solution step by step. We have a 10-pound block moving at 4 feet per second when a force equal to 8t squared pounds is applied horizontally. The coefficient of kinetic friction is 0.2. We need to find the block's velocity at t equals 2 seconds. First, we convert the weight to mass by dividing by 32.2, giving us the mass in slugs. Looking at the vertical direction, since the block does not accelerate vertically, the normal force equals the weight, which is 10 pounds. The kinetic friction force is then mu k times the normal force, giving us 0.2 times 10, which equals 2 pounds. This friction force acts opposite to the direction of motion. Applying Newton's second law horizontally, the net force is the applied force 8t squared minus the friction force of 2 pounds, and this equals mass times acceleration. Since acceleration is the time derivative of velocity, we can separate variables and write mass times dv equals the net force times dt. We integrate both sides, the left side from the initial velocity of 4 feet per second to the unknown final velocity, and the right side from t equals 0 to t equals 2 seconds. This is equivalent to the impulse momentum principle. The change in momentum equals the net impulse. Evaluating the impulse integral, we integrate 8t squared minus 2 with respect to t, giving 8t cubed over 3 minus 2t, evaluated from 0 to 2. Plugging in t equals 2 gives 64 thirds minus 4, which equals approximately 21.333 minus 4, or 17.333 pound-seconds. Substituting into the impulse momentum equation, we have 10 over 32.2 times the quantity v minus 4 equal to 17.333. Multiplying both sides by 32.2 over 10 gives v minus 4 equals 55.81 feet per second. Adding 4 to both sides, the final velocity is approximately 59.8 feet per second. To verify, we check that the net impulse equals the change in momentum. The impulse integral gave 17.33 pound-seconds. The change in momentum is mass times the change in velocity, 10 over 32.2 times 55.8, which also equals 17.33 pound-seconds. Both sides match, confirming our answer of 59.8 feet per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.